All right, let's go on to the last part of the tutorial. I know it's late in the afternoon, and so the last part of the tutorial will be actually lighter in the content, and also hopefully more entertaining. And we are going to cover large language applications of large language models for two-sided marketplaces, as well as talk about simulation. So what are large language models? So we have seen large language models in media, in the news a lot. They are transformer-based language models trained on a lot of text data collected from the internet, from everything that we have generated in the textual form. And compared to traditional NLP models, they are capable of understanding and generating human-like text. So it's a really big step forward in terms of the interaction between the human and AI and the algorithm. And the capability of large language models are also amplified by the advancement in research in automatic speech recognition, as well as voice synthesis. So in the context of voice AI agents. So basically, in addition to textual form of the interaction, you can actually listen and talk to AI, which is in the human form and also talks in a human-like voice. And why is an LLM important in marketplaces, right? So first of all, large language model, they are able to enhance user experience through natural language interactions. So instead of the traditional form of interacting with an app or interacting with a menu-like customer support agents, here interacting with large language model actually is is very much natural, just like we are talking to our colleagues. And large language models are also able to improve decision making, for example, pricing and incentives, by helping us analyzing unstructured data. For example, such as reviews and chat logs, right? That is particularly strong strengths of large language models, that they are able to find insights and also find patterns and process a large amount of unstructured data. They can automate customer support and search and recommendations and more that's relevant in the two-sided marketplaces. So we also have heard about large language model-based agents a lot. So in terms of modeling, they are actually similar to the reinforcement learning agents that we have already discussed in the previous sections. But instead of interacting with the environment through signals or through features, state features, these kind of large language model based agents, they interact with human beings through language, natural language, as a communication vehicle. So that is like a much easier form in terms of communication and getting feedback signals from the environment. There have already been a lot of development in LLM-based agents. In, for example, customer support, we have seen a lot of companies developing LLM-based agents to automate customer service, in developing agents as legal assistants that helps lawyers to prepare documentations and doing the paralegal works. we have seen examples in shopping guide. So, for example, Amazon has developed the agent called Rufus that helps you to navigate around the Amazon website. They can do sales marketing, both inbound and outbound, and creating and maintaining sales leads for salespeople. You'll see later on the demo for restaurant phone agent. So, for example, for restaurants on the delivery platform, they can deploy LLM-based agents to automate a lot of their business operations. Like, for example, taking customer orders. Coding is another example that we have seen a lot in the news. Recent advances in LLM, they enable agents that help us automate and write a lot of code, and also helps in debugging in the form of a so-called Copilot, right? And as I mentioned, the capability of LLM is augmented by the advancements in natural language and speech recognition and voice synthesis to develop the voice agents. So voice agents, traditionally, they come in the architecture that divides into 3 stages in that sequence. So the first stage is speech recognition. So the voice agent first needs to be able to understand what you say through your voice, and translates your voice into text. And then it's in the middle, it's your cognitive layer, which is usually powered by a large language model. So basically, taking in the text generated by ASR, the cognitive layer is responsible for generating a response that makes sense and that also basically helps to complete the task of the conversation. And in the bottom layer, or in the last stage, that's voice synthesis, the TTS, the text to voice translation. So basically, that acts like artificial voice to speak the text response from the cognitive layer, and so that really makes the AI agent human-like. There are already a lot of applications of large language models in specifically for two-sided marketplace. So first of all, we mentioned customer support. LLM-based agents can automate the handling of common inquiries, like for example, lost and found, or customer complaints about their rights. The customer support agent can talk to and interact with customers, and also potentially suggest the resolutions and follow-up steps to help mitigate and resolve the cases, or in the automated manner. So they help a lot in terms of reducing the response times and definitely improve user satisfaction. The second type of example is personalized recommendation, right? So we can use LLM to analyze user preferences and to suggest relevant products and services. Examples are like on the food delivery platforms, LLM agents can help recommending restaurants based on past orders and reviews. They can help in dynamic pricing and incentives as well. So we mentioned about using LLM to analyze unstructured data. For example, pulling information from social media and reviews, and to use that information, that insights, to adjust pricing strategy. So basically, information from those sources would give indication about the customer sentiment, for example. But traditionally, it's hard to collect and extract those insights in the straightforward manner. LLM agents can generate personalized incentives for users. For example, discounts and promotions. And we talked about in the section about policy optimization that there are optimization around the timing and targeting groups when it comes to incentives for growth, incentives strategies. And here, LLM-based agents potentially can help on that as well. And lastly, fraud detection, right? We can use LLM to detect fraudulent activities by analyzing, logs of user activities on the platform, and also analyzing the text data or suspicious messages. So here are two specific examples with different types of two-sided marketplaces. So Lyft has recently partnered with one of the major LLM providers, Anthropic, to enhance its rideshare services, right, by developing customer-centric LLM-based products. So in this case, LLM-based agents enhance and automate customer service request handling, and reducing the average resolution times by a huge margin, 87%, and significantly improving the customer service throughput. Basically, the amount of customer service requests that you can process within unit time. And within the picture of the marketplace, it helps. It basically helps rider engagement and retention by providing a better experience in customer support. Second example is about the Instacart. Instacart has integrated a large language model in its search system to enhance product discovery and user engagement. So they combine LLM's extensive world knowledge with their own domain-specific data, and the platform is able to offer more relevant and inspirational content, and so that to address previous limitations in search result diversity and relevance. So challenges and future directions. There are, although there has been a lot of advancement in large language model and development of LLM-based agents, there are still several long-standing challenges there. First of all, the accuracy in agent response, which is hampered by hallucination in large language model. Hallucination is basically agent response in a way to fabricate certain information, which is not fact, and that may lead to undesirable consequences. Like for example, in the restaurant ordering system, if the agent somehow allows a user to order something that's not on the menu, that's definitely not undesirable. And logic reasoning is another challenge that impacts accuracy in agents' interaction as well. We all know a large language model, as out of the box, it has limited capability in terms of logical reasoning. Although we have already seen, there are reasoning specific models like DeepSeek R1 or OpenAI, the OpenAI O1 model or O3 now. But those are not one-shot large language model, but instead they carry out a chain of thought in a sequence at the back end. Bias and fairness. So this is another challenge to basically, we want to avoid biased recommendations or responses that's generated by AI agents. Scalability and compute. The inference and training of large language model requires a lot of compute resources. And on the application side, basically, we desire the handling of large volumes of real-time interactions, especially for large-scale marketplace systems. So the compute resources and complexity, and how to make the inference stage more efficient, that's continued to be a challenge. And as we see the development of agents, there are a couple of directions that they are going in the trend. So first of all, it's multimodal agents. Not only that the agent is able to communicate and interact through text, through voice, they can combine that with image, and also, for example, with interactions in the sideline, in the canvas, right? So all of that multimodality helps the experience of the interaction. The second one is basically real-time adaptation. We all know the marketplace dynamics are constantly changing. The environment is changing. Customer preferences are also changing. So agents need to adapt to those dynamism in the marketplace through, for example, continual learning. So basically, agents able to take feedback signals and data from the real-time interactions and continuously improve itself in terms of the quality of the response. So after introducing various examples of large language model agents and what they can do, let's actually look at a live demo. I'm going to. This is a voice AI agent sitting behind the phone. So I'm going to call that demo restaurant and place an order of a pizza, and let's see how large language model based agents are able to automate that process.
Welcome to Pizza My Heart in Sunnyvale, California. What would you like to order today?
Hey, can I order 3 Watsonville apple pizzas?
Did you mean the Watsonville apple pizza? If so, please let me know the size you would like for each of them, 12-inch, 14-inch, or 18-inch.
Yes, I want 18-inch. Is that enough for like 5 people?
Yes, an 18-inch pizza is usually enough for about 4-5 people, depending on their appetite. So I'll add 3 18-inch Watsonville apple pizzas to your order. Would you like anything else?
I think that's good for now. Thank you.
Great. Your order is 3 18-inch Watsonville apple pizzas. Please remember to pay through the payment link you'll receive in a text message after this call. You can pick up the order from our store. Thank you for choosing Pizza My Heart. You can hang up whenever you're ready.
Okay, thank you. Yeah, so that quickly completes a telephone call that placed an order of 3 pizzas. On the for example, on the food delivery platform. And then after the call, I'll receive a text message that confirms the order, basically lays out the what I have ordered in my phone call, and as well as providing a link for the payment, so that I can pay before I go to the store to pick it up or for delivery. And next, we are actually going to talk about simulation, right? So we have talked a lot about policy optimization. We have talked about policy evaluation. Simulation is actually an important integral part of developing algorithms for two-sided marketplaces. And so basically, they allow us to test policies without real-world risks. A lot of the policies are have high stakes, like for example, pricing policies, matching policies, any any issues in those policies on the production system, they'll have a significant impact to the customer experiences, and also have impact to the platform's reputation, for example. So simulation provides a safe environment, like for us to understand marketplace dynamics under different what-if scenarios. So the one challenge in the real world is that it's really hard to test out like those what-if scenarios, because you have to execute those actions in real world, and which may carry a significant risk. And through a simulation environment that allows you to conduct like experiment of what-if scenarios simultaneously, like for example, over a large number of cases. There are two major types of simulation, macroscopic and microscopic. The macroscopic simulation basically involves high-level modeling of the marketplace dynamics. And the microscopic simulation, as the name suggests, they involve detailed modeling of individual agents. For example, in the rideshare platform, those agents are drivers and riders, and that kind of a simulation is usually achieved by agent-based modeling. And we'll see examples of each type of that. So first of all, macroscopic modeling. The main purpose is to understand the impact of interventions in supply and demand on marketplace efficiency. So what if scenarios is like if we carry out a incentive campaign on the supply side or on the demand side, which may affect the supply volumes in specific time and locations by a certain amount, and we can use macroscopic modeling to basically to look into what kind of possible consequences that we may get through this kind of interventions. So the GEM model, Hongtu has already talked about that in early part of this tutorial. GEM, which is the graph-based equilibrium matrix. Its original form is a generalized asymmetric Weierstein distance between supply and demand. And in GEM, the dispatch effects is accounted for through solving an optimal transport problem. And we have extended the work into a dual perspective framework, specifically for two-sided marketplaces. So in here, the supply-demand gap index that's derived from GEM, we interpret them as expected market conditions from the random driver or a random buyer or random rider's perspective. So that provides you a pair of perspectives or indices on supply-demand gap, and the shift in that dual view of indices actually offer a lot of insights on changes in marketplace efficiency through a decomposition of the shift vector along a pair of orthogonal directions, which corresponding to shifts purely in the volume, which is like supply or demand volume influx into the marketplace, and the other orthogonal direction is the changes in distribution of the supply demand, and hence more directly related to marketplace efficiency. The microscopic modeling, in this particular example, it's tries to study the dynamics of growth of the marketplace through modeling individual agents, and it uses this specific simulation tool called MassSim, which will also introduce and talk about it in the later slide. And it develops the agent participation model, basically a choice model over transportation modes and participating and competing platforms. So it models the choices of the participants, the riders and drivers, or in other type of agents, and their willingness of participating in this particular marketplace. Right, there are competing transportation modes, like for example, taking taxi or taking public transportation, or being involved in a competing platform, like for example, Uber versus Lyft. And that participation model considers endogenous factors like driver income, rider waiting time and price, as well as exogenous factors like marketing of different platforms, word of mouth about the time varying reputations of the platforms, and it analyzes and establishes that model specifically through S-shaped learning and adaptation that allows us to evaluate different platform policies. And the concept of a generative world model for simulating two-sided marketplace is actually still an emerging area of research. This is a neural network-based generative foundation models employed to create realistic simulations of market dynamics, and that enables the study of complex interactions between participants. And in the very recent work, the team develops a financial market simulation engine powered by a large market model that generates order level data that reflects actual market behavior and allows testing and developing trading strategies in a controlled environment. But nevertheless, the applications of such generative foundation models to simulate traditional two-sided marketplaces are still quite limited. And on the related theme, the work of Sean and team applied generative adversarial imitation learning GALE to model driver behavior on driver incentives on the rideshare platform, and also simulate competitor effects. So they train simulation policies that mimic real-world decisions that captures both the platform actions and driver responses through accounting for and at the same time accounting for hidden competitor policies, like for example, a competing platform. And the multi-agent generator models the interactions between drivers, competitors, as well as platforms. And at the same time, the compatible discriminator ensures that these learned behaviors align well with the real-world data. And this approach allows one to create realistic simulations while utilizing historical data to optimize platform driver incentive strategies in such a dynamic marketplace environments. There are a number of tools and frameworks for doing simulation for two-sided marketplaces, and there are a few practical considerations for choosing the appropriate one. So first of all, the complexity. We need to assess the intricacy of interactions between participants and choose a tool that can actually capture these dynamics effectively. Scalability, right? The tool has to ensure that it can handle the scale of our simulation, especially if we are modeling large marketplaces with a large number of agents involved. We need to consider programming expertise. Some of the tools require more advanced programming skills, while others not. So we should select a tool that aligns with our team's programming skills. And lastly, specificity to domains. General purpose agent-based model tools may offer more flexibility, but domain-specific simulators like MarsSim can provide more tailored features for the particular types of marketplace under consideration. So here we show a specific specific tool that's for simulating general marketplace and agent interactions. It's called the Repaste. It's basically a suite of agent-based modeling tools that support the creation of agent-based simulations in various domains, like not only for ride sharing, but for other types of businesses as well. It's open source, and there are two variations. Like one is for more standard modeling tasks, and the other one is tailored for more high-performance computing scenarios, especially for simulating larger scale marketplaces. You can use that to simulate complex systems, not only two-sided marketplaces, but the main point is to understand the interactions between the different participants. And to simulate rideshare specific dynamics, there are a few important aspects to cover. This work from Yao and Becker, they laid out the detailed design of a rideshare simulator. Although the application is a hitch service, strictly speaking, so it's a very specific type of ride sharing where the driver is actually also a rider itself. The design actually can easily generalize to regular ride sharing as well. And the work from Chowdhury and team offers an OpenAI gene compatible environment. So that's particularly useful for training reinforcement learning policies. And if you have more advanced programming proficiency, the Armodus and MathSim are both Java-based extensible simulators that comes with a graph user interface and rich visualization tools as well. And for a better handle on marketplace participants' interaction and behavior, we have this, we mentioned that before, one of the works that we introduced actually used that as a simulation environment, the Marcin Mobility as a Service Simulator. It's an agent-based simulator designed for mobility services and allows us to analyze interaction between drivers, platforms, as well as riders. And it has been used to study market dynamics, including the rise and falls of mobility markets. And as a key feature, it captures day-to-day decision-making processes for both service providers and consumers to model their real-world behaviors. And it has been used to analyze market entry strategies for new mobility services where you may not have already historical data to analyze because it's a new service. But nevertheless, you can simulate that if you have a good agent interaction model. And it has also been used to understand the co-evolutionary behavior of agents definitely in the mobility service as well. Simulating marketplaces presents several practical challenges, for sure. First is, again, scalability. As large-scale platform involves thousands of agents, that requires efficient computational resources. A high-level realism is often challenging to achieve to ensure simulation reflects the real-world dynamics, especially when there are human behaviors involved, which is especially hard to simulate because of the high level of stochasticity involved. Validation is another key issue. To compare simulation results with actual data. It's relatively straightforward to do on-policy validation, but off-policy validation is still very much a challenge. And additionally, in industry settings, simulation is often compared to production system outputs. So how to manage the all kinds of nuances from the production system and still keeping maintainability is something that continues to be explored. So that pretty much concludes this part, as well as concluding the entire tutorial for for decision intelligence for two-sided marketplaces. There are again a set of references that you can look into if you are interested. After the conference, we'll post the slides on the website. And here's the URL for the website, and as well as our contact information of the speakers. Yeah. So thank you, and enjoy the rest of the conference.